All right, so next up is Kasper from Dash Zero, talking about the paved path to observability. So what I heard is we will learn a lot about how observability should become part of a platform capability to make it easier for anybody to consume observability.
Exactly.
Yeah.
Exactly.
Observability is also a passionate topic for me, so I'm very excited to hear your thoughts. Thank you.
Cool. Well, welcome to this talk. So just quickly about me. My name is Kasper. I work as a Director of Product Marketing and Developer Relations at Dash Zero. I'm also, as Joseph mentioned earlier, former co-chair of KubeCon, Cloud NativeCon, together with him for some of the keynotes there. I also wrote this book, OpenTelemetry for Dummies, so if you're interested in getting started with OpenTelemetry, I have a few copies in my bag, so you can come up to me afterwards, and then hopefully I'll have enough, we'll see. I'm also a CNCF ambassador, and I like to challenge myself a little bit, so I also did all the CNCF certifications as well, so I was part of the first batch of Golden Kubestonauts announced last year as well. And I also do things similar to this event in Denmark and the rest of the Nordics. I've co-founded what we call Cloud Native Nordics, a meetup alliance across the Nordic countries. And we also have, I think there's been a few announcements of KCDs or Cloud Native Days throughout this conference already, but I have a fourth one maybe. So if you're in Denmark in November, we have Cloud Native Denmark there as well on the 19th and 20th. CFP is open, so feel free to submit. But enough about me. Let's talk a little bit about Kubernetes before we dive into sort of the observability side of this talk. Because Kubernetes came with a lot of things, and it changed a lot of things back, 10 years ago, 11 years ago now. It came with a lot of raw powers. It sort of gave us all of these primitives like pods and services and all the things that you know from Kubernetes, right? But it didn't really give us that product experience. There wasn't really like a default path or anything like that. So in the beginning, developers were struggling quite a lot with being forced to use and use kube control and apply all of these things and manage all of these things themselves. And I think I was at KubeCon in San Diego in 2019, and Brian Lyles did this awesome keynote. Can definitely recommend everybody to go find it on YouTube. But what he mentioned back then was Kubernetes is a platform for building platform. And he sort of extended that Kubernetes is the vehicle that takes you to your destination as well. So Kubernetes wasn't really the end goal. And he also, in that keynote, mentions that Kubernetes really needed to find its Rails moment. Because back then in 2019, again, there was all of these raw powers, the primitives were all there. Huge community, building and building and building awesome, cool stuff. But they didn't really provide that product experience, that opinionated defaults that came out of the Rails ecosystem. That developer experience was kind of missing for Kubernetes. And that's sort of what we sort of put in this graph. This is a good friend of mine. It's inspired by his talk, Daniel Bryant. You can see the original here. But what he really tried to convey is the cognitive load seen from the development perspective, or developer perspective over the years. So back in 20,000, in the 2000s, there was we built things like our systems as monolithic applications, and we sort of have clear boundaries that developers were developing these things, and we had production that ran these things, or the infrastructure teams that ran these things, and it was okay in terms of how much cognitive load a developer was dealing with. Then we started to distribute a little bit. Service-oriented architectures arise back in the 25, 6, 7 in that area, and it's sort of starting to grow in terms of cognitive load. Now the developers had to deal with distributed systems, network calls, all of these things. And then for a period, it's sort of the PaaS was sort of invented. We had Heroku and Cloud Foundry and all of these systems. And the cognitive load was really dropping, and it was more or less just git push Heroku master, and every developer really liked that. And then Kubernetes and microservices and cloud native came, and this just exploded from a cognitive load perspective of developers. Right now, they had to deal with, Docker containers, Kubernetes manifests, all these network calls, all of these different services that were running in production, and luckily, someone came up with this idea of that we need to put in a platform to absorb some of this complexity and just try to come back to somewhat similar to what we had with Heroku and the early days of building a PaaS, and we built platform engineering, or platform engineering emerged as this discipline to sort of cope with all of this complexity. So we had the developer interacting directly with Kubernetes back in the day. I did the exact same thing. I was actually at a conference back in 2017 talking about, because I was working at a company that was just adopting Kubernetes. You're just pushing like manifest to all the developers, go deploy these things, you manage the Docker containers, it's all good from my perspective as an infrastructure person. So now developers can just do everything. But we really fast found out that this was not a good idea. Developers didn't really have time to manage the Kubernetes manifest. A lot of things were happening at this time as well. So there was every Kubernetes release, something new came. Security was becoming more hardened. A lot of things that we couldn't really push on the developers. So we needed to build something in between. And that's really where we started to build a platform and put in something that could absorb some of all of this complexity and make it easy for developers to get things out into these environments. We still have Kubernetes and all the raw powers underneath. We just have a platform that makes it more accessible and more easy for developers to consume. So developers are getting happy again. And if we sort of frame this and I really like this quote by Evan Butcher. So we built this platform, and the platform is really like a digital or a foundation for self-service APIs, tools, services, knowledge, and support arranged as a compelling product. So really building something as a product that is really something that the developers enjoy using is really what this quote is about. And then we saw team topologies also coming in and defining what a platform team is. Again, this is a group of team types that provide a compelling is again a word in this, to basically accelerate the delivery by stream-aligned teams. And now recently, I think it was last year in KubeCon Atlanta, there was this book or O'Reilly report published by the Centasso people, Platform as a Product. And it's again a similar mindset. Now we treat our platform products or our platform as products. So we have, again, opinionated defaults, workflows, and we just build an experience around how we are providing things to our developers. So that was really the missing abstraction, this platform and now treating these things as products. So how does all of this relate to observability today? I think we've seen some of the same mistakes, just in a different domain, because there's been a lot of momentum, there's been a lot of different signals that are popping up, and we know more and more in this space. We have a lot of different options to choose from as platform engineers out there. But we haven't really found that good opinionated default that provide that experience, and that's what we will dive into now. So observability kind of promised a lot, right? That we will get faster root cause analysis, that we will be able to understand the system behavior, that we will get lower MTTR. When something breaks, we could just fix it and go back to sleep. I guess 3 AM was mentioned as the time of night that developers are woken up, so I guess that's also in my talk now. But it's really about reducing guesswork. But I think the reality is where do I actually start? Which tool should I use? And now I adopted this CNCF tool, and why is this metric now suddenly spiking from this thing? And it's also a lot of human correlation, because we have, at least in many cases, we have logs in one system and on one tab, we have metrics in another, and traces in a third, and maybe we have some profiling tool, or we have some real user monitoring in a fifth tool. So we have a lot of correlation that we as humans and as developers or as platform engineers need to do in the head. So we take one ID from one system, pop it into another, trying to figure out what is actually going on. So it looks something like this. Because these different tabs, of course, naming is also hard, right? So we are not probably aligned on what we call things in a different system. So actually looking up a thing from one system and another system is also becoming quite hard. So finding that needle in the haystack when something goes wrong can be really, really hard. And especially with the complexity and the growth of our infrastructures today, with now hundreds of thousands of microservices, this is becoming even more problematic. Yeah, that was the needle. So the current reality is really a lot of fragmentation in this space, because all of these tools that you saw in the different tabs up there also have their own complex query languages. In many cases, there are some vendor logins somewhere. Either you need to run an agent, you need to add a framework or a library of some sort that you need to add to your code, making it even harder to actually get out of this again. There's this metadata inconsistency that I was talking about before, that one thing is called one thing in one system and another thing in a third system. And then in many cases, people only choose to instrument one or two signals, just because of the sheer complexity of getting insight from all of these different tools. And that, of course, leads to lack of unified insights across all of the different signals. And if we take a look at sort of the timeline, we've seen a lot of complexity, more and more services, more and more telemetry, cost is going up, but we haven't really seen like that drop in MTTR, because more data doesn't necessarily mean that you will be able to find things faster. So that is a problem. And yeah, Gartner also has this quote around up to 84% of current observability users struggle with cost and complexity of their daily monitoring responsibilities. So there's just a lot of problems in this space that people are suffering with these days. And this isn't necessarily a tooling problem. I think you probably all heard about the 3 pillars of observability. And as you saw in my tab slide, there was more than 3. So I think we should really stop talking about the 3 pillars of observability, because there is more, and let's call them signals instead. Because we don't really have a metrics problem or tracing problem or logging problem, we have systems problems. It's our systems that are really the thing that we need to understand what is going on with. And each of these pillars are like providing a partial view into that problem so that we can actually understand in full what is actually going on. Yeah, I usually bring this. It's a nice little manifesto that I think John Gallagher created. So if you want to sign a manifesto on trying to kill the 3 pillars, you can look that up. It's pretty cool. I think many of the big observability vendors are part of this as well. So it's just a cool thing to try and get rid of this 3 pillars of observability. So same mistakes as early Kubernetes. As you can see up here, there's a lot of different tools in this space. So this is only the observability sort of category within the CNCF landscape, and there's so much to choose from. The cool thing is that OpenTelemetry is also up here, which is like a foundation for a lot of these tools today, and now it's actually not even incubating more. This is a little bit older slide. It actually just graduated last week, which is awesome. I have a celebration slide in a second. But the cool thing is that there's a lot of powerful primitives in this space, but there's no like default experience. So how do you create that as a company, as an organization that tries to put this out to your developers so they can actually get the insights in what is going on? So OpenTelemetry is really where we are going. It's a shift where we are moving from these scattered signals to like correlation across these different signals. So that allows you to find related information across different signals, but it also allows you to go, so if you see a metric spikes, you can jump into the actual distributed trace, find a span, and within that span you can see the logs. You can jump easily between the different systems. And that really allows you to reconstruct the chain of events when something goes wrong, so you can actually resolve your incidents much faster. And this shift is really towards OpenTelemetry as sort of the foundation for all of this. If you're not, how many are familiar with OpenTelemetry? Just, okay. How many are running it in production? A few, that's good. So just like briefly what it is, it's an open source project now, a graduated project within the CNCF. But what it really tries to do is to provide standardized tools and APIs for basically generating, collecting, and exporting telemetry to somewhere. And it's originally focused a lot on tracing. That's where sort of it originated, but also support metrics, logs, profiling, browser as well. So there's all kinds of different signals that you can use and observe through OpenTelemetry. And the main goals of the project is really to create this unified telemetry, be vendor neutral, and be cross-platform, meaning that you can instrument your applications in whatever language you're using. There's an SDK for that, or there's tools to figure out how to do that, which is really, really cool. Now the celebration slide. So I think this is awesome. It's been going on for like a year since the original like PR was created for the project to graduate. So it's awesome to see that it's finally graduating and becoming part of that like top tier project within the CNCF. So let's give that a big round of applause. So in a nutshell, what OpenTelemetry is, it's really a data model. It's API specifications. It's what's called semantic conventions. If you're not familiar, it's really, again, it's tackling that naming problem. So we all agree on what things are and what units and values they can take. It's also all of these libraries and SDKs for all the different languages, so you don't have to go to a specific vendor or anything. You can just use what the open source community is providing. And there's a lot of utilities in there as well. There's a collector for collecting all your telemetry. I'll show you that in a second. But there's also an operator that allows you to do this from a platform perspective as well. But we'll come back to that. But what it's not proprietary. It's not an all-in-one observability tool, so don't expect when you run OpenTelemetry that you just get everything out of the box. You get sort of the collection part of it. You still need some tool or something to visualize all your signals in. So there's no data storage, there's no query language. Yeah. This is just to show that there's a lot of momentum going on behind the project. It actually supersedes Kubernetes on, I think that's PRs plus issues last year, so there's really a lot of momentum and buzz going on. And also from the CNCF survey this year, it actually had 49% of all the respondents to that survey said that they're running OpenTelemetry in production, and an additional 26% are evaluating it. So there's a lot of momentum behind this. And it's really, if you're not looking at it, you should probably be looking at it right now. So the signals, I already mentioned these, so metrics, logs, and traces are sort of the stable signals, and then we have profiles and real user monitoring as well. But the cool thing is really, and the superpower of the project is that it really allows you to do correlation between all of these signals, so that you can actually correlate, a specific span to a log that took place during that execution. So that is one of the cool things. From 1,000 miles view, this is sort of what you would get. You will have an OpenTelemetry collector somewhere running in your environment. Maybe you'll have more of them, depending on how you want to configure that. You have some instrumentation in your applications. There's multiple ways of doing that. You can either do this manually, or you can use the auto instrumentation. I will show you that in a second. You can also observe all your infrastructure. I think there's, in Kubernetes alone, there's 5 different receivers for getting kubelet information, getting the Kubernetes API, getting all of the events, so you can get all of the nice things out of your infrastructure as well, and not only Kubernetes, but basically any tool out there to some extent has a receiver, so they can actually get data into it. And then you send your data to some backend. You can do, of course, some awesome stuff in there. You can do processing, you can do redaction, you can do just remove all debug logs if that's the thing. You can do all kinds of things in that pipeline before you send that to your backend somewhere. And that backend can also be one backend, or it can be multiple backends, depending on how you set that up. That's really a platform engineering choice. So the collection of telemetry is now standardized by OpenTelemetry, and that's really what the difference from what we are coming from. Because before, vendors were sort of fighting over the full picture of this, also around what data could they collect in your environment, but now that is a solved problem. Now vendors are competing further down the line around how to be the best possible solution with the data that you're providing or sending in. Just briefly about context, because I think telemetry without context is just data. This is just an example of this. So any guesses to what this is, or what this could be? It's just a graph going up and then it falls down. Any guesses? What? Requests per second. That's a good. It could be requests. It could also be voting. I don't know, like Trump's approval rating. I don't know. It could be anything, right? But actually, in this case, it's sort of the cuteness versus number of legs for animals, because the context in this case really matters, right? And it also does for when you're collecting your telemetry. We can talk about system context on all kinds of different levels. We have the infrastructure, we have the platform that's running on, which container was actually running this thing, what was the service name, and who are we actually gonna call when something goes wrong. So all of this, almost, there's a semantic convention for that, which was what I was mentioning before around OpenTelemetry having this standard for naming things. And all of the links here, you can see this is links to semantic conventions. The only thing missing is sort of on the organizational level at the moment, but I know there's work being done in this, so that we actually can also standardize and define who's actually owning this thing. But it's just to say that the context around your telemetry is really important to get collected as well, so that you exactly know that this service was running on this machine in this data center, or whatever it might be when something goes wrong. Because that is really the platform engineering role, is to observe the platform and provide all of this information, and then enable developers to basically get this out of the box. And if you treat observability as tooling, contra observability as a product, you probably just like buy some tool. Maybe there's a terminal they can do something and they have to manually configure some YAML files, or they manually need to set up like basically the instrumentation part. All of this becomes sort of the developer's problems. Whereas if you treat it as a product, you provide like a clean UI, you provide an experience where all of this is basically just being done for you as a developer out of the box. You don't have to spend time and understanding in how the actual infrastructure is working. And I'll show you how to do that in a second. So the goal would then be to just have it as it just works. So you can create this paid path for observability where you build in all of this, like all of this should just be coming out of the box by default at a certain sort of foundation of what is interesting telemetry coming out of that application. And the key in all of this is really auto instrumentation changes sort of this game, because you don't have to manually go into all your, REST calls and all your functions and instrument those out of the box. You don't have to do that. That is really sort of the job of auto instrumentation, to inject something that allows sort of the instrumentation to take that out and forward that to your observability backend. There's many different ways to do instrumentation. I will talk a little bit about the no-touch instrumentation, which is really doing this using a Kubernetes operator instead. And this is also where OpenTelemetry provide a solution, because it has this operator that allows you to inject this auto instrumentation thing, whether in Java it's a Java agent, in Node.js, I think it's like monkey patching. So there's different ways of how the project itself like solves this issue. But what it basically does is that you can add an annotation to your Kubernetes spec, and then automatically, whenever that is applied to the cluster, you will get instrumentation by default. It will have the configuration to where your collector is running, and it will forward that to your observability backend. So OpenTelemetry is really about how telemetry is produced and collected. You need to figure out, as a platform engineer, how you're stitching together the different tools. But having OpenTelemetry as sort of the foundation allows you to really change this as you go, because it's fairly easy to just add an exporter to someone else, to try out a different vendor, to try out an open source thing, or whatever it might be. And then you need to also figure out how do you provide that experience on top of all of this to the developers that are actually using the telemetry that is being collected. And also nowadays, we, as Joseph was also talking about with AI and all of this, we have this new persona, an agent that are starting to use our data as well. So I'm seeing that a lot of our customers are using the MCP server to basically get information and talk to the telemetry and getting something back. And I guess we're going to see more and more of this. And why AI needs a platform first? Well, if you put garbage into an AI or an LLM, you get garbage out, right? And I think the cool thing about OpenTelemetry is that now we have the semantic conventions and the specifications, and if you then use the tools to send the data conforming to these specifications, then you will actually have pretty good results, which is quite nice. So if you really want to do something cool with AI as well and incident resolutions in this space, you probably need to think about the foundation of the data that you are sending in and basing this on. Because I think the interaction mode is probably also changing. This is just like a quick screenshot from our product, but it's changing into a more natural interaction mode where you're asking questions about your system. How is my service doing today? What is the latency? Or what is up? Tell me what is going on. To probably in I don't know, a couple of months, or probably already in many cases, this will just happen automatically, right? That an agent tells you, here's a report, this was going on. Maybe it actually even created a fix for whatever was going on. So we are entering into a new world where a lot of this is going to be really interesting to follow. And also from an end user perspective, this is going to be really, really nice, not being woken up at 3 a.m. in the morning. To start investigating and manually correlating across all of this. You just get the report. Maybe you just approve a PR, or maybe it's already done for you. That is not what I'm going to show you, because that is not existing. But I'll just show you quickly, sort of from a platform engineering perspective, how this could look and how you can create this. So I just have this cluster running locally on my machine. It's a kind cluster. I have a few collectors running. I'm running 2 different collectors, one as a daemon set, so I have an agent running on all my on all my nodes, talking to the kubelet, fetching, like picking up logs, etc. Then I have a more central one that can talk to the Kubernetes API and get some more like data around, deployment, replicas, stuff like that. Then I also have the OpenTelemetry operator, which is basically what is instrumenting all of my applications. And let me just quickly go back here, because just to give you sort of a visual understanding of what sort of the demo is, I will just do it like this. So we have a front-end application, a to-do service, it's a backend, there's a database, and now I need to create this validation service that basically just like gives a thumbs up or thumbs down for whatever the to-do is. And just for the fun, I have some asynchronous stuff going on as well, because that is also possible and easy to basically get information out of Rabbit, but I probably don't have time to show you that today. But let's just quickly jump back to that and show you the actual application. That was not the application, this is. So by some, I don't know, hotel swag, so we can add this as to do. A message is coming back from the notification service, so the asynchronous part is also working, that's fine. And if we go in and see in Jaeger, then we just find, we have a create to do. So now I have a span, I have the services that are communicating, that's all great. So now I want to create a new service that takes part of this distributed trace automatically without me as a developer having to do anything. So my platform team in this case have created, or are using Backstage to basically create abstractions and make it easy for me as a developer. So what I do is I go back into Backstage, I create a service, that's awesome. This is cheating a little bit because this is the actual service. In a real scenario, you will probably have like a template for this is a node service, this is the defaults of how you would configure that. So I'm creating a service, that's nice, it's being created. Just to show you that this is actually being created, we can do, so we have the validation service now. It was created May 19, that fits the time. We can take a quick look at the service itself. It's basically just a Node.js service that has an API that basically validates whether or not the to-do includes bad, terrible, or awful. If it does, then it just returns 400. Shitty service, but it's to show the point. So if we go back here, take the next steps. My platform team has been so nice to create this small CI/CD service, let's call it that, because I don't really have like a full infrastructure. But what it basically does is that it builds the service and deploys it into Kubernetes. So now it runs in the cluster, hopefully. Validation service, yes. Then I have a small feature flag in the to-do service, because the to-do service then needs to call the validation service to just make sure that it actually works. So let me just add that feature flag and quickly check. An error, awesome. Let's try again. Perfect. It usually goes like that. We find the right screen. So if I do bad now, it fails. So the service is now part of this and it works, that's great. So if we go in and look at the actual traces coming out of this now, you can see now the validation service is part of the trace. I didn't touch anything, there was nothing in the code specifically that told or had anything specific around this is being instrumented or I need to create this span or anything like that. This is just coming out of the box by the operator. And just to quickly show you how it's done, I have this line in my Kubernetes manifest that basically says inject Node.js, and then it points to an instrumentation resource CRD that defines this is where the collector is running and all of these things. And when this is deployed, it gets all the environment variables and all of that configured out of the box. So that's basically how you can start building this into the platform so that your developers are automatically getting instrumentation out of the services. So, however, there's a ton of different ways you can do this. So Backstage was just one way of doing this. You can choose all of the other tools like crossplay new build, you can use credits, whatever, how you basically want to create all of these abstractions is up to you. Just quickly on why OpenTelemetry, it really allows you to instrument once and you can use this everywhere. It separates, as mentioned, the generation from the analysis steps. And then a lot of the frameworks out there now comes with this out of the box, so you don't have to do anything, which is also what you saw there. And then it improves how we use telemetry. And then platform as a product or observability as a product, well, it's basically about creating that experience for your developers and making it as easy as possible for them to get the insights they need. And yeah, quickly, if you want like a digital copy, scan this QR code. Otherwise, come talk to me afterwards. I have a few. Merge forward is awesome. I don't have much time, but just check it out. I know the QR code wasn't working yesterday. It's working now. So if you want to check it out, it's awesome. It's a nice, check it out. I don't have time. And thank you so much, and get in touch.